Assalamualaikum everyone, my name is Ubakir Ali. Welcome to my YouTube channel. If you feel lost when you are solving past paper questions of work, energy and power, this video is specifically designed for you. So let's dive in. We are going to solve past paper questions of paper 2024. Okay, so what the question is, a ball is a ball of mass m is thrown up the height h in the air with the initial velocity of v. The air resistance is negligible. So if the air resistance is negligible, it's mean the acceleration will be constant, right? What is the total work done by the gravitational force on the ball during its flight from P to Q? This is P, this is Q. So the object is going all the way, it's following this trajectory, okay? So as there is no air resistance, what are the forces acting on it? The force that is acting on it is the only force that is weight. And we know the weight, let's suppose object will follow this path, the weight will only act vertically downward. And if you remember the definition for the work done, it is the work is equals to force multiplied by the distance covered in the direction of force. So if you see, we have to check the vertical distance, how much vertical distance is covered, right? So it's starting from height 0 and it follow this trajectory and all the way it come back to the height 0. So there is vertical work done is 0, vertical distance covered is 0, so work will also be equals to 0. There will be no work done by the gravity, okay, because there is no other force acting on it. The only acting force is the gravity, and the vertical distance not covered, it's coming back to the same height from where it is launched, okay. So it is option A we have. In the next question, question 2, what is the definition for the power? So it's pretty easy question. Power is defined as work done per unit time, right? In the next question, what we have, a model car travel at a constant velocity of 12 meters per second in straight horizontal line. The input power to the engine of the car is given. So what information we have? We have the velocity, we have the input power, we have the efficiency. What you have to find, you have to find total resistive force, okay. So the relation of efficiency with the power is, efficiency is equals to useful output power divided by total input power, okay. This can be converted from percentage to a number. It will be 60 divided by 100, and power output is P is equals to F into V. We have this relation for the power, so you can write F into V. Input power is already given, that is 800 watts. So what we can do, F can be written as 60 into 800 divided by 100 into V. V is given, that is 12. So let's do the calculation. When you do the calculation, you get 40 Newton. So it's option B we have, okay. So let's move to the next question. Which statement represent the principle of conservation of energy? Okay, so energy cannot be used faster than it is created. That is entirely wrong. It's a very basic question. The supply of energy is limited. The total energy is closed system is yes. Total energy in a closed system will always be conserved, okay. It will not change. Okay, the next question, they are telling a barrel of mass 50 kg is loaded onto the back of a lorry 1.6 meter high by pushing it at a frictionless 3.4 meter long plank. So this is the length that is given, the height is given, the mass of this thing is also given. What is the minimum work done? Okay, so what information we have? We know this thing is frictionless. So again, as it is frictionless, the only force that you have to deal with is the weight. If you have to lift this thing, weight will try to pull it down and you're going to push it right above the height on the plank. So the only weight will be the force that you have to deal with. Friction is there is no frictional force, frictionless plank. So if this is the object the weight will be vertically down. So there are two components of weight. One weight component will be along the plane downward, right? And one component will be, you can, perpendicular to the plane. Okay, it's almost, let me make it, let's make it like, so this is perpendicular to the plane, right? And from our previous knowledge, we know that if this angle is theta, this will also be theta. So this component will be mg cos theta, and this will be mg sin theta. Okay, you can simply memorize this thing as well. The component of weight down the plane will always be sin theta. Okay, so but we don't know this theta in this thing. Okay, so we need a little knowledge of trigonometry. If you see this thing is making a triangle, and we can apply the sine identity to find this theta. We know that sine theta is equals to perpendicular over hypotenuse, so this can be theta is, let me, sine theta is perpendicular is 1.6 and this is 3.4. So theta can be written as sine inverse 1.6 divided by 3.4. Let me do the calculation. When you do the calculation, that will give you 28.07 degrees. Okay, so now we know this force exactly, because we know mass, we know g is 9.8, we know theta is 28. So to find the work done, what you need this distance. This is already given, so the work done will be, I can write it as work is equals to force. Okay, so as we know, work is equals to force multiplied by the distance in the direction of force. So it can be, force is mg sine theta and distance is d. Let's put the values. We have the mass, it is 50 multiplied by 9.81 into sine of 28.07 degrees multiplied by the distance, that is 3.4. So doing the calculation, this thing will give me 784.73, that you can round it off to 780 joules. So we have option C, that is correct. Okay, in the next question, a stone of mass 0.3 kg is thrown vertically downward with the speed of this from a height of 12 meter above the ground. It falls vertically until it hit the ground. Air resistance is negligible. Kinetic energy of the stone just before it hit. Okay, so let's suppose this is the stone that we are talking about. This can be the ground level, and this thing is moving down. Okay, and its initial speed is 20 meter per second, and the height from which it is falling is 12 meter. You have to tell what will be the kinetic energy at this point. So its kinetic energy at this point will be half mv square, but we don't need this. We just need the kinetic energy at higher. Okay, so what information we know? There is no air resistance, right? So at this point, object have some kinetic energy initial, plus at this point it will have some potential energy. As there is no air resistance, so this all the energy is simply converted into the final kinetic energy. So I can say the kinetic energy final will be equals to kinetic energy initial plus this mgh. Basically this mgh will also convert it into the potential kinetic energy, because at this point potential energy will be equals to 0. All of the potential will be converted into the kinetic energy. Okay, conservation of energy we will apply, so it will be mgh. You just have to put the values. Kinetic energy we know mu square plus mgh, so 1 by 2. Mass is 0.30 and u is 20 square plus mass is 0.3 into 9.81 into height is 12. Okay, So when I do the calculation, 0.3 into 2 okay mga, that will give me 95.3. that can be rounded off to 95, so its option is D. Okay, and the next question: a student can run or walk up the stairs to her classroom. Which statement describes the power required and the gravitational potential energy gained while running up the stairs compared to walking up? Okay, so you have the different options. In this option, C is correct. What you need to know, if you see the energy is, if you are talking about the potential energy, it will be mgh, and but when you talk about the power, it is energy divided by time. So power depends on time. Okay, power depends on time. So speed, basically more speed mean if he is running faster, it will spend less time in doing that thing, right? So less time need more power. Okay, so power is something that can be changed with the speed. If you are moving slowly, you are taking more time. More time mean less power. Okay, so energy is independent of that thing. Energy just depend on how much distance you have covered, how much height you have gained, and what was the mass of the body. Okay, pretty simple question. And the next question: a weight hangs from a trolley that runs along a rail. The trolley moves horizontally through a distance p and simultaneously raises the weight to the height q. Okay, what they are telling, this is the trolley that is moving in this direction and this weight is hanging with this thing. So when this thing moves there, this weight will also be moved there in the rightward direction, but this thing is pulling it upward as well. So as it is moving right, it will gain some height as well, so it will follow this path. So it will keep on moving like this. Okay, so there is only one force that is acting on this thing, that is the weight. You have to find work done. Okay, so work, again the same thing, it is the force multiplied by the distance. Which distance? Distance in direction of force. So if you see, there is one force only, that is the weight. There's no air resistance or anything else, right? So weight act vertically, so you have to see when it is moving from this point to this point, how much vertical distance it has covered, that is this thing. So this will be your D. So you can say work is equals to, force is basically the weight multiplied by the Q. So this is option C, that is right here. Okay, and next question: the equation for kinetic energy can be derived using the equation of motion. You have the four different options. Which three equations can be used to derive the equation? Okay, so for this you need to know how to derive the kinetic energy, then you can easily choose this thing. By the way, the right option is option A. Why it is right? Because we can derive very easily. We know that work done is equals to F into S. Let's suppose this is some object, you can say it is some football or something. You are going to do some work on it. When you do some work on it, it will gain kinetic energy. So you can say so this mass will start accelerating, right? So you can say the force that is applied will be equals to ma. Okay, so and this work is equals to ke. So work is ke and force can be written as ma, and this is s. Okay, so if the acceleration is constant, we can apply a conservation equation of motion on that thing. So a can be derived from v square is equals to u square plus 2as. From there I have a is equals to v square minus u square divided by 2s. You can put this thing here. So kinetic energy will be m into this thing, v square minus u square divided by 2s into s. So this will be cancel out, so you will be left with m v square minus u square, sorry, there will be another m divided by 2. Okay, and if object is starting from rest, then you can take u is 0, so you can write ke is equals to half mv square. So this is the derivation for this whole kinetic energy thing. Okay, and the next question: A box of weight 40 Newton is pushed with a horizontal force of 20 Newton along a ground. So let's try to understand the scenario. This is the object. It's pushed with a force. The force acting on this is 20 Newton and it has covered a distance of 2.4 meter. Okay, when it reach at this point, the box is then lifted at constant velocity through a height of 1.6. so now you have to lift this thing. So let me make it here. Okay, so what we are going to do, you are going to lift this thing. Okay, at how much height? 1.6 meter height vertically. What is the work done on the box by the two forces? Okay, so the box is eventually here, so you have to find first, you have to find this work done. So the force acting on during this journey, it will be 20, distance is 2.4. then what you have to do, you have to find this work done. Okay, how much force you have to apply there? This force will be equals to the weight. So weight multiplied by the distance, 1.6, weight is already given, that is 40 into 1.6. You calculate these values and then when you add them, the final answer you will get is 112, that can be 110. So okay, so option B is correct. Okay.